Nick, thanks for taking the time again to join me, just to elaborate more on what we were talking about previously. So, when we were last talking, we were talking around steel conduit tube and the key things to look for when people or customers are sourcing their conduit tube. And one of the key drivers is the marking, which should be on every length of tube, which denotes the brand, the current standard that that tube adheres to. And you've got these 4 digits on there as well. Now, Metpro Tube has 5, 5, 5, and 7. First of all, could you just break down what those numbers explicitly mean?
Okay, well, just to be clear, these numbers are taken from the British Standard 61386-1 2008 A1 2019, and basically these this is an amendment to that standard, which requires the numbers to be shown on the product and stamped on them. So they are within the standard. There are 13 individual tests that need to be done, and then these numbers relate to the first 4 tests in that standard. So the first one is resistance to compression. Now, just to clarify, this standard deals with conduit, be it PVC, right through your flexible conduits, all the way up to rigid conduits, metal conduits. So reality is that obviously a PVC conduit is not going to be able to withstand the same endurance pressures and everything else that a metal one would. So the requirement for these markings is to identify really what conduit you are actually promoting through this standard, because the standard is so wide. So, okay, let's come on to the classifications themselves. The first digit is against resistance to compression. So on that one, we've put 5. That is the highest classification, and it's described as very heavy compression strength. And then the second one would be resistance to impact. Again, we have a 5, which is the highest classification, heavy strength. And then the third and fourth one relate to temperatures, and so you've got the lower temperature range, which we consider ours to be minus 45. That's the highest classification within that, and then the fourth digit being the upper temperature range, which is 400 degrees. Again, that's the highest one within that. There, for us, that's what we would expect to see on class 4 metal conduit.
Okay, so of those 4 numbers, then you've got the first 5, which is impact. You've got compression. The second 5, which is impact. So, what's involved for a manufacturer to achieve those numbers, to achieve the highest level in those classifications?
Okay, so let's just take the compression test. Now, in order for our product to meet the 5, it basically needs to withstand 4,000 newtons pressure. Now, that's done by applying a block, about 50 mil by 50 mil block, onto the top of a tube, which is laid on a firm base, and then the force is applied steadily, and it has to achieve 4,000 newtons. Then, if you move on to the impact test, that's more of a sudden test, if you like. So the weight is taken to a height of 300 millimeters, and then is dropped down, and the weight itself is more of a point. So when it comes down, it makes an impact into the product. So it's 300 millimeters drop, a weight of 6.8 kilograms, and that, if the product survives that, then that achieves the class 5 as well. So there are specific apparatus tests that are defined within the standard to classify those two ratings.
Okay, and then with the last 2 digits, the 5 and the 7, on the lowest temperature and the highest temperature, is there any testing for that, or is that just purely governed by the material itself?
Very much governed by the material itself, and you'd expect these to be there, because these are probably the clearest indicators as to what product, what conduit you're actually referring to. So obviously you'd expect plastics to be very low from a temperature upper and lower range, but then obviously the metal ones to be much greater than that, and that's it's borne out in the classifications we've got for these.
And what would happen then if somebody sourced their tube from somewhere, and it's got all the markings on as you would expect, but instead of 5557, you've got, say, 4357. Just an example. What would that mean?
All that basically means is that conduit has been tested to lower levels of those classifications. So, for instance, if we said the compression force was their number started with a 3, well, that's 750 newtons pressure applied. Put it in context, ours is a number 5, and that's 4,000 newtons applied. So it just basically means that they've gone for a lower rating in those particular classifications. When you're talking about class 4, though, the expectation is this is a rigid, solid metal conduit that it achieves the top classes.
Okay, and just out of interest, then, because we clearly state in almost every communication we put out about our conduit tube that we manufacture every length, certainly at 2025 mil, with a minimum wall thickness of 1.37 millimeters, which increases as you go into 32 and up to 2 inch. If another length of tube, an alternative tube, is manufactured with a thinner wall thickness, would that render it or make it more likely for those, certainly the compression and the impact testing, to be of a lower class?
Very, very likely, yes. I mean, we wall thickness is not governed within the standard as a dimension. For me, it's done in a much better way than that, because all these tests that are applied to the product are safety tests to understand its endurance, strength, and it's governed by that. So really, for me, all I would say is if somebody is going for a lighter gauge wall, then it is very, very probable that you would not be able to achieve the highest classifications within the standard, and you'd have to drop down the classifications. Yeah, absolutely.
Okay, and obviously with that as well, you make it much more likely to see other issues such as the material tearing when it's being bent, or I think even recently we've heard some stories of box threads stripping through the actual material of the tube. So not exactly ideal when you're when you're part of a chunky installation.
Well, not at all. And I think, we're talking about strength right now, but just from a practical point of view, the pitch of a 20 and a 25 mil thread, if you apply that to a tube which has a thin wall, just by the pitch depth alone, it is likely to penetrate through it or certainly make show marks on the inside of the tube. And if you're starting to see them, then that means you've got very little material left in those areas. So whilst wall thickness is not governed within the standard, it's certainly an important thing to consider when you're talking about applying threads to products. Yes,
absolutely. Yeah, and I suppose that's just one of the many reasons we feel so confident giving a 5-year extended warranty against our system as well. Okay, Mick, look, I think we've covered what we needed to as part of this little update. I mean, the reason for getting together again was, as you know, off the back of a few people inquiring as to what exactly these numbers mean, and a bit more of a breakdown. So hopefully we've answered those questions for those people and anybody else that's watching this now. And no doubt I'll speak to you soon. And thanks again.
No problem.